Hey everyone, it's Kenny. In my last video, you learned how to build a customer service AI agent from scratch in Python. And today we're going to build on top of that. I'm going to show you how to 100x your agents using MCP. You are going to learn how to build your own MCP server, learn how to create a client that can connect to multiple MCP servers, and unlock your agents by giving them access to powerful new tools, resources, and prompts through the MCP client. We're going to start with a quick demo of what we're going to be building today by calling uv run main.py. We are running a FastMCP server. This server is called memory. This is set up with the stdio transport mechanism. Don't worry if you don't know what that means yet, we're going to cover it. But essentially, we're starting up this local server. And this isn't the only server that we're using, so I have another tab open here. This is for retrieval, and you can see the transport mechanism here is different. It's streamable HTTP, and so this you can imagine being a remote server that's hosted somewhere, and we're using the HTTP protocol. We're connecting to these couple of MCP servers that we're going to build together. And here I'm just quickly printing out what are all the tools that are available to us through these MCP servers. Each MCP server has its own set of tools, and so to differentiate between the tools from different servers, we have a prefix with that server's name. So these first two tools come from the memory MCP server, and then we have a couple of more tools from the retrieval MCP server. We also have a couple of local tools that are not part of any MCP server. We're just defining them as local functions and then giving them to the agent. Finally, we have resources and prompts that we're going to expose from our MCP servers. These are going to be coming from the retrieval MCP server, as we'll see in a bit. But yeah, let's see what this agent can do. So I'll kick things off by just asking the agent for a particular product. So I'm going to ask, what running shorts do you have? And right away it's going to call a tool. You're seeing all of both the tool calls and the tool outputs, and so that's why you're seeing a lot of text being printed out right now. But the agent decides to call this search products tool from the retrieval MCP server right away, and it's passing in the query, which is running shorts. For gender and category, these are metadata filters that the agent can narrow down its search by. And you can see for gender, it passes none because it's not sure if I'm actually a male or female yet, since I haven't specified. The category, it does use running since it's inferring that from the question that we asked it. So this is going to be the response from querying our products catalog. And then it's able to answer my question with that context. It's summarizing this product, and it's also saying that there is another running wear, the Speed Strike running tights and Cloud Step running shoes, if I'm interested. Do I want more details on the shorts, or do I want to see other apparel? I'm going to move my camera because it's blocking here to the top. Do you have a preferred color or size? I like black, and I'm a size medium for shorts. So it's asking me some information about myself. I'm going to go ahead and give it those details, and it's calling these memory tools. So it has one to manage memories. In this case, it's creating a new memory, and it's noting my preference for black running shorts. So that's really nice. It's able to store my preferences and personal details to make all of the interactions that it has with me as a customer as personalized as possible. I'm going to ask it, these look good. What's your return policy? Here it should look at the FAQ. So in the knowledge base, we have an FAQ document. It's calling this tool from the retrieval MCP server again, looking for the return policy under the category of returns. So it's going to go ahead and get that context and give us a grounded answer. So you can see it's a 30-day window, and it will also mention that there is a $5.95 return shipping fee for refunds. And so if you look at the tool response here, this is coming directly from that knowledge base. So we have our answers completely grounded. So that's really nice. Next, I'm just going to ask it generally if it has any other recommendations for me. I like the shorts. Do you have any other recommendations for running gear? This one has a lot of output, so we're going to see exactly how this breaks down in a bit. Let's scroll up now that it's done answering. So you can see it calls this retrieval analyze customer tool, and it's passing in my user ID, which is just 1. The response from here is a very detailed analysis of the customer, which is Vlad. So customer 1 is Vlad, that's me. And it's breaking down what my most common purchase categories were, what my most common purchased products were, inferring information from those purchases like my likely preferred colors, even though I haven't necessarily told it, besides in our conversation saying that I like black. What's the most likely purchase amount range, or what am I willing to spend on a typical purchase? And it's inferring all of this from my purchase history. And it's also going to generate some other insights. So this tool is actually the prompt tool. It is a prompt that we're pulling from our MCP server. So you can see how powerful this is. It generates this really detailed analysis as a tool response. And it's going to use all of this context that it now has about me to search the products and then give me some personalized recommendations. Here we get our 3 recommendations for running tights, running shoes, and a shirt. And we can kind of expose the thought process behind this by asking, why are these good recommendations for me? So asking it to kind of expose its reasoning. It doesn't know that we're seeing the printouts of all these tools, right? So it doesn't necessarily know that I have that full context. Its reasoning is because I have a strong interest in running and I prefer high quality gear. Also for the running shoes, you can see this part where it says it's complementing my previous choices of premium running shoes. So that is again coming from that analysis and my previous purchase history. So all of this is grounded. It's making these personalized recommendations for me. And that is again being powered by the prompts coming from the MCP server, which we'll see in a bit. Now, in a real application, you wouldn't want to expose all of this to your user. So for example, if I scroll up, I'm printing everything out here, including all the tool calls and tool responses. Obviously, for us as developers, we want to see all of this information, and you would probably log this on your backend, but we'll see how we can use a toggle in the app to hide these sensitive tool calls and tool outputs from the user, from these printouts in the console, and only expose the tools that we want to make public to the user. So we'll see how we do that in a bit as well. But yeah, that's the full agent that we're going to be building today, giving it access to MCP server tools, prompts, and resources. So if you haven't already, I highly recommend you check out my last video where we built this customer service agent from scratch in Python, because this is really a continuation of that project. There we covered everything from making your first API call to get an LLM response, tool calling, retrieval, memory, the agent loop, all the way until we had eventually a full customer service AI agent. But if you already watched that video or you just already know how to do all that, then we can dive right in. To get started, head over to the AI Launchpad repo, which will be linked in the description. This has all of the code for all of the tutorials on this channel. And you're going to want to follow the getting started section, which it's just 4 steps to get set up, and then you'll be able to run any of the tutorials in this repo. 3 steps if you already have UV. But yeah, you're going to want to start by setting up UV to manage your Python projects, which is super easy. clone the repo locally, and then run the command uvsync, which is going to create a virtual environment for you in your project directory, as well as install all of the dependencies. And then finally, you're just going to want to copy the .env example into your own .env file and set up the two API keys that we're going to need in the agents module for today, which is the openai API key and a Tavily API key for web search. So once you do that, you should be set for running any of the code. Hopping over to the project, once you have it open in any IDE that you work with, I'm going to be using VS Code. We're going to be working in the agents module today under the project agent with MCP. So like I said, this is a continuation of the agent from scratch, which we covered in the last video. And there's going to be a few new components to this, but we are going to be reusing some of that code. Let's start with the sample data that we're going to be using for this project. It's in this CRM-DB folder, and we're using a JSON file with some sample data or dummy data here. There's only a few samples in here. We have a users table with 3 records. And you can see user ID number 1. This is the user that we were using in the demo. So that's Vlad. We also have a transactions table, which is going to have 4 records. And these belong to different users. So this is going to have past purchases from our different users. Let's check out the tools directory. This is where we're going to be setting up our local tools as well as our MCP servers. To start off, the tools.py file, this has our local tool, but this is just super simple. We're using Tavily to search the web. So that's our only local tool. Let's check out the first MCP server, which is the more simple one, and that's the memory MCP server. So again, I'm not going to go into a ton of detail on all of the tool implementations themselves. I'm mainly going to focus on the MCP part, since we did cover creating these tools in the last video. Before diving into creating our first MCP server, I first want to talk about the MCP project itself, as well as the FastMCP library that we're going to be using today. So if you head over to the official GitHub repo for the Model Context Protocol, this is the official project. And if you scroll down, you can see that they have SDKs for all the major languages. We can go check out the Python SDK. If you've worked with MCPs before, then you might recognize the FastMCP Server class that we typically import from mcp.server.fastmcp. This repo or this module is actually an official project. So if we go over to the FastMCP repo, this is its own project, and it's an open source project that was developed by the company Prefect. Prefect is basically a workflow orchestration. It's kind of like Dagster, if you've heard of that. But anyway, when they originally developed this library for FastMCP, which is basically setting up your MCP servers using a framework that's similar to FastAPI, that was incorporated into the official MCP project. So that's why if you go over to the Python SDK, you'll see that you're importing this FastMCP client from this module. And again, that was originally developed by Prefect and then incorporated into MCP. So the project FastMCP has since evolved on its own, and it has continued being developed by Prefect and the open source community, and now has a ton of more features, fixes for issues in the original. And so now they have a V2 that's been released, and that's actually what we're going to be working with today. I think going forward, it's a much quicker developing project and a pretty robust library for working with MCP. And like I said, this is going to have capabilities and features that are not present in the version 1 that you'll get with the official MCP Python SDK. They have really nice documentation for the FastMCP project, so I will go ahead and link this documentation in the description as well. Really quick, I'm not going to go into a ton of detail on what MCP is, how it works under the hood, and why it's actually important. I covered that in other videos, so I'll link those in the description if you're interested in learning more, but we're going to focus more on the application of MCP here. Okay, now that we got that out of the way that we create our MCP server is pretty much the same. So we bring in this class that allows us to instantiate an MCP server, and you can do so by just passing a name for the server. These are some of the bells and whistles that I mentioned that V2 is going to have that weren't necessarily present in V1, which are things like middleware, but you can explore everything again in the documentation. There's a lot that you can do with these servers now. But the usage is pretty much the same. Once we instantiate that MCP server, we're going to be able to use the @MCP or whatever you call your server here. We're going to be able to use the decorator by calling @MCP.tool. And this decorator is going to convert any of our Python functions to tools. This is the same tool we created in the last video to create, update, or delete memories. You could pass in a name here to give it a unique name or a different name than what the method is called. Otherwise, the name of this function is just going to be used for the name for the tool. And same with this get memories tool. And again, we're just registering it using this tool decorator. So once we do that, this is the most basic MCP server. You instantiate your MCP server, you add tools to it, and then in order to run this MCP server, all we have to do is call mcp.run. And you always want to put this in your if name equals main block so that this only runs when we run this as a script. Now, if you don't pass anything to this run method, this is going to default to a transport method of stdio or standard in out. And that's good for prototyping or running local tools. It's going to be much faster than communicating with your servers over HTTP. But if you want to have a remote server, if you want to host it somewhere, then you will have to change this transport method to HTTP, which we'll see with the retrieval MCP server in a bit. But that's basically what you need to run an MCP server. So this memory MCP server is now fully functional, and we can run it by just running this file. If you want to just verify that you did things right in setting up your own MCP servers, there's a couple of ways to validate that really quick. So going back over to our terminal, here is the agent with MCP project. You want to cd into tools since that's where we're defining our MCP server. And there you can see our memory mcp.py file. I'll clear this. So you can just run this file directly and ensure that everything runs properly. So I'm going to use uv run memory mcp.py. And you can see the FastMCP printout here. And in the console printouts, you can see that the server was started properly. The other thing that you can do is run the inspector for any MCP server that you develop locally. This does require Node.js, so if you don't have that on your system, then you can just go to nodejs.org, install that, just look for your system here. And once you have that installed, then you can run a command like this. And this will basically create a virtual environment and run your file with just the dependencies needed. So it doesn't have to install anything extra. So we can highlight this and then go over to the terminal. And you're going to want to type npx at model context protocol /inspector. And we're going to use uv here. So it's going to be uv. And since we're in the tools directory, which has the memory mcp.py file, we're going to specify that the directory is just the current directory. And if it was in a subdirectory, then you would use this pattern here to point to it. And then we're just going to type run and then the package name without any arguments. So it's going to be run memory _mcp.py. So if we run that, then you should see the MCP server start up. And then you'll get a window which just opened for me over here that looks like this. Let me zoom in a bit. Here is the MCP inspector. This is just a really nice little UI to inspect your MCP server and kind of test it out when you're developing locally. So on the left, you have kind of the settings for the server. We're using the stdio transport mechanism, and we're using the UV command to run it. And then these were the arguments that we passed. At the bottom here, you can see that it says currently disconnected. So we can just hit connect, and it's going to go ahead and use this command to connect to it. Here you can list resources, resource templates, and you can see the different tabs here. So I can go over to prompts and also list prompts as well as tools. For resources, we don't actually have any resources. So if I just click that, you can see nothing pops up. Same thing with prompts. Yep, no prompts. And then if we go over to tools and we hit list tools, now we can see a couple of tools pop up. So here are the manage memories and the get memories tools. And you can click on this and test it out. It's going to also show you what the output schema is for this tool, as well as whatever metadata we have here. Let me collapse that so we can click on run tool. And if we scroll down, we can see that we successfully called the tool on the MCP server, but there's no output since there are no memories yet. So we can also test the manage memories tool. Remember that we can use this to create, update, or delete memories. So I'll just say create. I'll give it an ID of 1 and then say Kenny was here. And then I'll scroll down and then run this tool. Again, we get success. Kenny was here was created. I'm not sure why that's a -4. Did I type -4? Okay, I guess I typed -4. I don't know how that happened. But yeah, we created a new memory here. So now if we go back to this get memories tool, since the server is still running, this was created in memory, right? Remember that dictionary that we created in memory now has that one memory. So if we click on run tool, it's going to print the memories dictionary. Here's the memory that we created. So that's how you can play around with your MCP servers that you're developing locally and just make sure that they're working and troubleshoot them before actually plugging them into your agents. Hey, thanks so much for watching. I hope you're learning something from this video. If you are, consider dropping a like since it helps out my channel a lot, and consider subscribing if you want more content like this. Also, feel free to drop a comment if you have any questions or anything was unclear in the video. I respond to all of them. Thanks. Now that's the easy part, right? We just set up an MCP server, the most basic kind, where you're just exposing some tools and then running the server. It gets more complicated than that, but it also gets more powerful. We're gonna head over to the retrieval MCP server now. And again, we already implemented a lot of this retrieval functionality in the last project, but here I'm going to show you how to use the other powerful features of an MCP server, including prompts and resources. And to start off, I wanted to show you that you can add custom routes, since this is basically built on top of Starlet, which Starlet is the underlying library that FastAPI is built on top of. And similarly, FastMCP is also built on top of Starlet. So that's why everything kind of works the same between these libraries, and you'll notice a lot of the similarities between these frameworks. To set up a custom route, we're going to use the same @MCP decorator and call this custom route function. The first thing we're going to pass is the path. Whatever our server address is, this is going to be @/health. And we're going to specify that the methods we're allowing here is a GET request. So if we receive a GET request, then we are going to respond for this health check with just the text OK. And that's a way to, again, just test and make sure that the server is up and running by just running a simple GET request or doing a curl or putting this address for the server in your browser, as we'll see in a bit, and then be able to really quickly check that the server is running. And this is really nice because, again, this is pretty much a fully featured API. So you can add whatever routes you need to on this. And similarly, as we saw earlier, you can add middleware and auth all on top of your MCP server. For the knowledge base, I'm not going to go into a ton of detail since we also already covered this, but essentially we're going to set up a ChromaDB knowledge base that's going to have our embedding vectors for a couple of JSON files, including our products catalog and our FAQ documents. And if you do want to check that out, it's in the Agent from Scratch project. And you'll see this knowledge base folder here. And here you can see what the underlying sample data that we're using is. Once we set up the knowledge base, we have the same tools that we defined before. We're going to have our search products tool, and we're also going to have a search FAQ tool. And then now here is where we are going to also expose a resource on this MCP server. Resources are basically read-only data sources that you want to expose through the MCP server. So you can think about it like a GET request. And here I'm showing an example. We're just returning this hard-coded string, but you can imagine for this MCP server, we have a product catalog, we have an FAQ, and you might want to track when those things were last updated, right? So when did we last update the descriptions in our product catalog or add new products? So if you had that information on your server, then you can expose that via this status/last updated. And so this is a really quick way to check from your front end or from your application, just like you would with an API, when the server was last updated. So that's just one example. You can expose all kinds of things though, like server logs, if you have hard-coded documents, README files, API versions, whatever you can think of as far as data goes that you have on the server that you just want to make available to the front end. And I think it's also important to note that this doesn't necessarily mean that you're going to use these resources with your agent. As we'll see in a bit, you can use resources just like you can call tools yourself within your front-end application without routing it through an agent. So you can call this resource from your AI application and use the data or information however you need in the application separate from the agent. The one thing that's unique about resources is we do have to pass in a URI. So that's going to be a string. And this URI is going to be used to identify this resource. The first part of the string is similar to paths or routes in an API. So it's an easy way to group resources. And this is what makes it unique, is the name of the resource in combination with the path. So I could have another resource here, for example, that said status ://version, for example, and that would be another unique resource. Let's move on to the next part. So this is where we get into some new code and we're building on top of the previous example. I have this function that I created that will generate basically a JSON object or a dictionary that's going to have a detailed report for a given user. So this is going to be profile data, and I'm pulling this from that CRM database that we saw. So I'm just opening that file. I'm loading up the user's data as well as the transactions data. I'm going to filter down by the user ID that's passed into this method. And I'm also going to look at the purchases for that given user ID. I'm going to pull the standard data from the user table, but I'm also going to add these custom metrics like total purchases, which is just going to be the length of this past purchases list. I'll also calculate the total amount that they spent, the average purchase amount, and then just list the details of those past purchases. What I can then do is use this function that we just created to profile a customer and add it as a resource. So here I'm registering a new resource, and you can see we're using a new slug here. This is going to be user : / profile, and at the end we're passing in a input parameter. So similar to calling an API post request. So the user ID gets passed in as an integer into this function, and then we're going to go ahead and call that internal get user profile data function that we just defined up here. And the reason why I just defined it separately up here is because I'm actually using it in multiple places. So I can just define it once and then use it again and again. So this is a more advanced example of a resource where we're taking in some input data. And again, that could either come from us in the application, or it could come from the agent calling this resource as a tool, as we'll see in a bit, and passing in a user ID. Finally, we have the MCP prompt, which I feel like is the most underutilized part of MCP. So let's talk about the prompt that we're setting up here. First, to create a prompt, it's just going to be, again, using the @MCP decorator with this prompt function. We don't have to pass anything into it, but again, you can give it a custom name along with some additional options. Now, we're going to register this function, which is to analyze a customer. And the important thing about prompts is we're just returning a template prompt to the client, which is just a string, right? So we're going to have a function that either statically or dynamically produces a string, and that's what's returned to the client. Here we're passing in a user ID, and we're going to use that in the profile tool that we just defined above to get a user's profile and inject that into this prompt. So you can see how you can dynamically create these template prompts. And this particular prompt is going to direct the LLM to analyze the customer profile and generate insights about that customer that can help us highly personalize their experience. To do that, I'm asking it to focus on a few things, like look at what are the most common purchased products and categories, which those two things on their own aren't that impressive, right? But we're also extracting other information that we can only do with an LLM, like what is the likely most preferred color or category that the customer might be interested in yet, or what is the most likely range that this customer is willing to purchase on their next purchase, as well as just leaving it kind of open-ended for any other insights that the LLM can find in this data. So prompts are really useful to get repeatable output that we want to use over and over. And in this case, we're going to be using this prompt for all customers every time we want to profile them and analyze them to understand their purchase behavior to make the most personalized recommendations that we can. You could easily put this in the system prompt for our actual agent, right? So why would you actually want to separate this out from a system prompt for our agent and put it in an MCP server as a prompt? Well, one reason is by separating it out, you're simplifying the system prompt for our agent. This is just one example, but you can imagine a bunch of other functions that we want to make, and we don't really want to overload the system prompt, right? In the system prompt, we want to focus on high-level objectives, tool usage, communication style, etc. for the agent, since it's directly interfacing with the customer. So that's one big reason. And the other reason is because we might not want to use this prompt with our agent necessarily, right? We could have another AI workflow or an LLM workflow where we're calling an LLM and just using this templated prompt to get a response somewhere else in our application, right? So it's reusable across AI applications and workflows and not just used for a particular agent. And that's the whole point of MCP. So hopefully this will become clear to you as we actually implement it with our agent and we see how it's actually used by the application. Finally, for this example, I wanted to show you that you can use a different transport mechanism. Here we're using HTTP and we're specifying the host for the server as well as the port that we want to run it on. And if you just put HTTP, that's just a shorthand for streamable HTTP. These two are the exact same thing. Now, similar to the memory MCP, we can run this in the inspector, but because we're also standing it up on this IP and running it as an HTTP server, we can actually interact with it directly through the browser. So I'm going to head back over to the terminal again. And actually, so we already have this one that we used for the demo. So you can just copy this IP up here, and then we'll go to it in the browser over here. So I'm going to open a new tab and go there. So when you go to the root, there's no actual root function that we set up. So you just get this error not found. But remember that we set up a custom route for a health check. So we can do a /health here. And sure enough, you get your OK message, and that tells us that the server is running. Now you can also go to /MCP, and you can see what we actually get here is a server error, and the message is not acceptable. The client must accept text/event stream. So this is because we're accessing this not from an acceptable MCP client, but this is basically the root address where all of the streamed events will happen from. Now we have our retrieval MCP server set up with resources, prompts, and tools, and serving over HTTP. Now I'm going to walk you through how to set up a client in your AI application. And if you want, I also have this demo file that kind of goes through things step by step. I'm not going to cover this in the video, but you're welcome to go through it. It kind of shows once you set up a client, what are all the different methods to access the tools, the resources, the prompts, etc., as well as calling tools from the client, getting prompts, and the basic functions of interacting with an MCP server via the client. But we're just going to jump right into our main application since we're going to cover all of that in a more advanced setting. So for our main application, we're going to start by importing an MCP config.json, which is where we're going to specify the configuration for our MCP servers. You can see I'm just loading this MCP config JSON file from the project folder. And if I open this up, this is pretty standard if you've worked with MCPs before. It's just a JSON that has a top level key MCP servers, and you have to make sure to lay everything out exactly as it is in this file because the library expects this exact structure and format. And I'll link the documentation below, but here you can see on the FastMCP documentation, they talk about how you would do this for both remote and local servers. So there are some additional arguments that you would pass here that we're not going to be using. For example, if you were using auth, you could specify the auth and headers here. And then if you have local environment variables, you can also pass those as well. So pretty simple MCP config.json. If you want to extend this, go ahead and add your own MCP servers to the tools directory, and then you can just add them to the JSON here to add even more tools to your agent. So going back over to the main.py file, we have our agent loop after that. And there's just a couple of new things we had to add to this agent loop. First, we're going to have this Boolean at the top, which allows us to quickly toggle whether we want to hide private tools. I mentioned this in the demo. If we don't want to expose certain tools to the user when we're printing out those tool calls and tool responses, we can set this to true, and whatever tools that we put into a list as private tools, which we'll see later, those tools will not be printed out in the agent loop. For the main function, we set the user ID again as 1 for our example, and then this is where we set up our client. So coming back to the top, so in the same way that we imported the FastMCP server class from the library, we're also here on the application side, we're going to import from FastMCP this client, and we're going to instantiate this client by just passing in the MCP config, which we loaded from the JSON. Again, if you have an MCP config JSON and it has multiple servers defined in it, this client is just going to take care of connecting to all of those servers at once and then being able to pull the resources from them. So really convenient way to interact with multiple MCP servers through just one client. So coming back down, the way we use the client is using a context manager, and that's just going to make sure that once we're done and we exit out of this function, we're going to properly close the connections with the MCP servers from our client. So that's for proper cleanup. Now remember that we are working directly with the OpenAI API through the OpenAI SDK. And so we have to specify the tool schemas and pass those tool schemas to the API every time we make an LLM call. And that's how the API will know what tool we're trying to call. When it comes to creating the list of tool schemas to pass to the API, we only have to do it for our local functions or anything that's not registered as an MCP tool. And that's because for any tools that we defined in the MCP servers, the tool decorator actually takes care of generating the schemas for the tools. So it's going to go and grab the name of the function, the description from the doc string, as well as all of the input parameters and their types, and generate this schema for you. So all we have to do here is manually define the tool schemas for the non-MCP tools. And the first one that we have here is our local tool for web search. The new thing that we have is this second schema, which is for the MCP prompt to analyze the customer, and that, remember, is in the retrieval MCP server. So what we're doing here is creating a function or a tool for the OpenAI API so that the agent can just call this as a normal tool. But in the MCP server, it's actually a prompt. And so whenever this tool is called, we're going to take care of calling the prompt in the MCP server to get that prompt back to our client. And you'll see that in a bit. But defining it as a tool like this just allows us to give the control over its usage to the agent. So after that, we're going to define this list that we talked about earlier, which is what tools do we want to make private. Now we can go ahead and grab all the tools from our MCP client. And pretty much all of the functions that we use to work with our client and server are async. So you have to await them. And that also means that we have to use an async function up here for our main method. Once we get a response from the client, we're going to have a list of tool objects. So if we hover over this, you can see it's a coroutine. So we're going to await it. And it's going to give us this list of tool objects, which are of type mcp.types.tool. So because they're tool objects, they're basically Pydantic models. You can access their attributes like this using tool.name or tool.description, for example. And we can go ahead and print out each one of those tools. Here for the terminal, we're also just printing out what local tools we have. And then we're going to extend that list of tool schemas, which we defined up here with just these two tools right now. We're going to extend that with now the list of new tool schemas that we've pulled from the MCP client. And we want to generate it in the specific format that the OpenAI API takes. So again, we're just going to use the same format where we're taking the attributes from each of the tools in the MCP tools list and then specifying these 4 parameters for the API. Then it's pretty similar for accessing resources and prompts. There's a list resources method and a list prompts method. In this example, I'm also calling an MCP tool directly in my AI application. So Remember that I said you don't always have to use tools and resources and prompts through the agent. You can use them anywhere in your application via the client. So here is an example where I'm going to initialize a memory to start off this conversation with the agent. And I'm just putting in here that this customer likes running. The next few lines are exactly the same as the previous video. We're going to create our initial message list, which is just going to have our system prompt. We're going to start our while loop and check to make sure that we haven't already reached the recursion limit. We have our check to see if we want to skip getting the input from the user and going directly to the agent. So anytime a tool is called, we're going to route directly to the agent instead of getting a user input. We're going to call the LLM API here, and we're passing in our tool schemas. And now this is where we have to add some additional functionality. So we're going to add the response outputs to the messages list to keep the conversation going. And then we're going to iterate through the outputs and look for function calls. And here is where we're going to add a check before printing the tool call, just to make sure that that tool is not inside of the private tools list, or that the setting to hide private tools is on. So if those two things are satisfied, then we'll go ahead and print the tool call. And now we're going to have a few cases for handling tool calls. So before, it was really straightforward. Normally we would just take the function call, whatever it was, and then call that local tool by invoking the function. So just like this, we have our local search web tool, and we would just pass in the function call parameters. But we have now a couple of new cases that we're handling. So first, if we get the retrieval analyze customer function call, remember that this corresponds to an MCP prompt. So what we can do is exactly the same way. When the agent calls this tool, it needs to specify a user ID. That's how we defined it in the tool schema. So we can still parse the arguments here and get those function call arguments, which should just be the user ID. And then instead of calling a tool, we're going to call this get prompt method. And we just have to pass in the name of the prompt as well as any input arguments. So that's what we're doing here. And then we're going to get back our prompt result. Then what we can do is take the text from this returned result, which we access like this, and we use that as the input to another LLM call. And this is going to now be the response from using that MCP prompt, which remember has the user profile injected into it. So it's going to go ahead and analyze the profile for this customer. Finally, what we can do is take the output from this response and then use it as our tool output or our function response. So we're just going to then append it as a normal tool response, and the agent can go ahead and take that as context. So this is just one way of using those MCP prompts as part of the AI workflow. For the MCP tools, it's even easier. We can just call this call tool method on the client, and we just have to pass the name of the function or the tool along with the arguments, and we're going to get the function response directly. So if you did follow the last video, then you'll notice that this isn't really too different. We just added 2 additional conditions here to separate out the handling of the MCP prompt as well as MCP tools. Last time we already had this local function calling. Similarly, if we wanted to use a resource in our application, we can just call the MCP client read resource directly using the URI. So for example, up here, if I wanted to print out the last updated status, let's say before we have the tool printouts, then I can do something like status is equal to await MCP. Oh, I think it popped up there. Read resource, and then put the URI, and then print out that status. So we could do something like this just to round things out. So if we run this now, we should see it here. So here's our resource at this URI, and there's the text that we hard coded on the server. So that's how you would read a resource in your application. And that's it. That is how easily you can add MCP to any agent that you've built from scratch in Python with whatever API you're working. So whether you want to do it with this FastMCP library, which I think is a great library to use, or you want to work directly with the MCP library, you can do that as well. But hopefully now you have a better sense of how everything works together and how tools aren't the only thing that MCPs are good for. If you're building AI applications and especially using AI agents, then the resources and prompts are also super powerful parts of the MCP servers. That's going to do it for today's video. Thank you all so much for watching. I appreciate all of you, and feel free to drop comments. Let me know what you think about this video. If you have any questions, I will be sure to respond. Check out the description for all of the resources that I mentioned in this video, and I hope to see you in the next one. See ya.